All right, so hi, good day, everyone. So today we will be doing January 2019, number 6. Now, number 6 is basically dealing with shapes. This is you either find the area, the perimeter, the volume, whatever they're asking you for. Right, so let's go straight to the question. The diagram below, not drawn to scale, shows an open cylinder container made of metal using a circular base and a uniform thickness throughout. The length of the container from top to bottom, right, from the top here to the bottom here is 120, and the inner is also and the inner and outer radii are 14 and 15 respectively. Now what that basically means is radii is radius, right? So if we were to draw a circle, let's just go through what is a radius. If we were to go through a circle, right, we have the center of a circle that is here, right? Your radius is from one point of your circle to the center of the circle. Right? So they're telling you that, let's say this is the center of my cylinder. They're telling me that from my outer to my inner, from my outer to the center of the circle is 15. Wait, the inner and outer. Right. So the outer would be 15 centimeters. So from the outside circle to the center of the circle is 15 centimeters. Let's make this a little bit smaller so we can see. All right. This is 15 centimeters. And then from the inner circle to the center, right? I'm going to put this in a different color so we can differentiate. I'll put this in blue. Is 14 centimeters. Right? So the outer circle, the outer cylinder has a radius of 15 and the inner circle has a radius of 14 centimeters. Right? They told you pi is 22 over 7. Now, pi is a constant. It is always 22 over 7 unless stated otherwise, okay? Right. So they said draw a cross-sectional view of the container showing the measurements of the inner and outer radii. Cross-section just means if we were to cut it across. Right? So if we were to cut it, we would have the outer circle is this circle here. Let's have no thing. And then the inner circle, there would be a next circle inside here. Right? Let's make this a little bit bigger. Right there. Actually, let's make this blue. So we know that the black circle is our outer circle and our inner circle is the blue circle, right? We have the center, right? So you're going to draw a center of a circle right here, right? And they told you that your radius, and I already did it, but we'll do it again. Your radius from your outer circle to the center, that's your radius, so half of the circle is 15 centimeters. So this is 15 centimeters, right? And then we're going from the inner circle, which is from the blue part to the center of the circle, right? We'll put that in blue so we can differentiate. That there is 14 centimeters, right? So if we look at this, if the distance from the center to outside here is 15, and from the center to the blue circle is 14, we can clearly see that this from here to here would be 1 centimeter, right? Right, and this would be your answer for part E. Now let's look at part B. Show the capacity of the container is 73,304. And when they say the capacity, we immediately supposed to think volume. Another giveaway that they're asking for volume is your Q. Anytime you see a unit is centimeter or meter, whatever unit cube, you immediately think it is volume. And obviously, if we look at the container, so if we look at the cylinder, what we are actually finding the capacity for is this cylinder that is inside the outer cylinder. So basically, we're finding the volume of that inner cylinder. Now, if you don't remember the formula for volume of a cylinder, please note that it is given in the formula sheet that is provided in your past paper. So if we look for volume of a cylinder, we see that the volume is pi r squared h. Right? So let us go back to the question. So we know that volume is equals to pi r squared h. Right? Let's make this bigger. And now we know, remember I said we're finding the volume of the inner cylinder. And we know that the radius of the inner cylinder is equal to 14. We know the height is equal to 120. This is given. And they told you that pi is equal to 22 over 7. So basically, if you know all of this, you're putting it in your calculator. Volume is equal to 22 over 7 multiplied by 14 squared, right, multiplied by 120. You can put this exact same thing in your calculator. 22 over 7 multiplied by 14 squared multiplied by 120, and you are going to get the same answer that. Okay, so instead of I made a mistake. Instead of 120, my height is actually going to be 190. 190. And why that is so is because if we look at our cylinder, right, we see that there's a thickness from here to here. Now, we already saw, right, that they told you that our cylinder is evenly, the thickness throughout is even. And we know that the thickness of the cylinder is 1 centimeter. So our thickness from here to here would also be 1 centimeter. But that 1 centimeter is not included in our inner cylinder. So if we were to look at the height, let's just put a shape here, from here to here, that is for our inner cylinder would be 120 minus 1, which is 119 centimeters. Right? So that is 119. So we are going to change this. So it's the radius is 14, the height is 119, the pi is 22 over 7. So our volume is 22 over 7 multiplied by 14 squared multiplied by 119. Put this exact same thing in your calculator. And when you do this, you get the same answer as above. That is 73,304 centimeters cubed. And that is how you would show the capacity of the container. Right? Now they said determine the volume of material used to make the container. Now this, what we'd have to do is find out the volume of our entire container, that is the outer, this outer part here, subtracted from the inner cylinder, and that is how we would find the volume of the material used. Right? So if we were to find the volume of the outer, cylinder, that would be same formula. We know it is pi r squared h, or r squared pi h, whichever one you want to do, right? We know that r for our outer cylinder is 15, or our radius, right? Our height is 120, and pi is equal to 22 over 7. So if this would be 22 over 7 multiplied by 120, multiplied by, let's put this in order, multiplied by 15 squared over 1 multiplied by 120 over 1. You use a calculator, you're going to get, let's just do this quickly, 120 and this is 15. You're going to get some, if you put it in your calculator, you're going to get decimals. Now, when you have decimals and you still have other parts to do in the question, always convert it to fractions. So you'll get 8, 4, 8, 5, 7, and 1/7 centimeters cubed. That is the volume for our outer circle. We already know the volume of our inner cylinder, which is what we found above, which was equal to, we're going to write up what we had, 73,304. 73,304, and all we have to do centimeters cubed to find the volume of the material used. Volume of material used would be, you subtract 84,857 and 1/7 minus 73,304. You could do this on your calculator, minus 73,304, and you're going to get, this is equal to 11,000, let me put the answer here, 11,553 and 1/7, or if you want it in decimals, remember you always put your answer to 2 decimal places. This is equals to 11,553.14 centimeters cubed. Erase this, right, to 2 decimal places. And that would be your answer for part C. Right? Just a quick note, remember the volume of the outer cylinder would be, let's put this in pink, this would be your inner, this is the combination of your inner cylinder and the material, right? So that is your answer for part C. Do this question. Part D says, given that the density of the material used to make the container is, so they give you the density. So density is 2.2 grams per centimeter cube, right? Determine the mass in kilograms of your empty container. We know, we don't know the mass. We do know the volume of your material, the volume of the material. Now, because we are using this answer above, we would not use decimals, use the exact answer, okay? So we will be using 11,553 and 1/7. Now, basically, we are making m the subject of the formula because this is what they give us. So if we're making m, we're going to carry across this, and the relationship between m and this value here is division. So if we carry across, divide by, it is going to turn to multiply by. So mass is equals to 2.2 multiplied by 11,553 and 1/7. So let us multiply that answer by 2.2, and you are going to get your mass. Now remember, this is in grams, huh? No, this is in grams, sorry. Your mass that we are calculating so far is in grams, right, is equal to 25,416 point, let's see, 0.91, right? All right, so this is in grams so far, but we want it in kilograms, and we know, or we're supposed to know, 1 kilogram is equal to 1,000 grams. All right, so let's do a if, then, and therefore. right? X of this, so we can have space. If 1,000 grams is equals to 1 kilogram, then 1 gram would be 1 over 1,000, and therefore we want 25,416.91 grams would be equal to 1 over 1,000 multiplied by that value, 25,416.191. I don't know why the 9 didn't come out here. 91 all over 1, right? So divided by 1,000, you're going to get 25.41691. Remember, we always give our answer to 2 decimal places, so this is going to be 25 point. Our line is going to be drawn between the 1 and the 6. The number after our line, which is 6, is more than 5, so you have to add 1 to the figure in front of our line. So it'll be 25.42 kilograms. And that is your answer for the last part, which is part D in number 6. Right? And that is the end of January 2019.